Hello, November 23rd. So this morning I'd like to work on problem 8. So we have to compare solutions to this guy and then some other m. Maybe we should rather use the other form, but I think that's better. Boom, 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 boom. And show that they have the same solutions. The solutions that are not covered here are the point at infinity, which is the same. And then I think it was 0.0 that it didn't cover. Yes. The affine point 0.0, which of course lie on both these curves. So we should try to make a map from a solution to this guy to this guy. This is to the fourth. I shall just check. Right. So if given a solution to either of these, we shall construct a solution to the other one. So let's assume that this holds. So I would like to multiply u by m divided by n and v times u, of course, and v, that should be multiplied with the square root of m over n. So if that can be done, so the question is, does the square root m over n exist? I think we are down in problem B, by the way, doing this. Aha! Actually, m over n is an integer. And it lies in FQ, and all the, so we call it alpha, and alpha over, or the symbol alpha over p to an equal r is always unity. So this square root does exist. And it's obviously non-zero, so the correspondence is 1-to-1. All right, next B. So let's try the same trick. And then n is multiplied by m squared so we can do that by saying u maps to squared u and v maps to m v. And that needs to be 1-to-1. So they are both in the multiplicative group. And why must it not be of characteristic 2? I don't get that. Well, let's leave that. So that was very simple technique. After stopping the recording, I realized why we needed characteristic 2, and that's the transformation from this equation to this equation that only works when the characteristic is distinct from 2. And that also means that I haven't found the transformation between the x and y's, only the u and v's. So we should just change it to be what happens with the x and y values. So x point y maps to, I take that from page 56. and they in turn were mapped to that's u point v, so u is multiplied by m squared, and y by m, and that we have to see where x point y is mapped. Now that's what I did. U point v is mapped to and here, of course, the necessity for character distinct from 2 is explicitly visible. So we add them, u plus v, and divide by 2. And then the second one we get by multiplying by v, so let's reduce the first guy, put them on the common denominator. This is far from simple. This is simple. But this guy is far from simple. And even if we reduce this to x third minus m squared, n squared, I don't see it at all. So in a sense, this was simple, but the resulting is far from simple. All right. I just wanted to show that the reason for character 2, and then of course finding out how x point y maps, but that turned out to be far from simple.